Hello everyone, my name is SUYASH and I'm a third year undergraduate student pursuing BTech in Engineering Physics from IIT Roorkee. Today I am going to present my project on facial recognition attendance system, which was a part of PHC 351 Fundamentals of AI/ML course. Okay, so let's start with the problem statement first. Whenever we talk about manual attendance, then it requires about 5 to 10 minutes for a class of 100 students. When the attendance is by roll call, then a lot of time is wasted. And a solution to that is location based attendance using the mobile app, but that has some glitches. Students use location changers, and sometimes it happens that 27 students are present in the class actually, but on the app there are 72 students present. So yeah, that's a big problem which needs to be solved, which I'm hoping to solve using this project. Yes, talking about my solution, it is an AI powered facial recognition system that automates the process of attendance marking in real time using a photograph captured by your smartphone's camera. Of course, the professor is going to capture the photograph over here. So like the process would be very simple. The professor has to open that mobile app and capture a photograph, and then faces would be detected, and here we can employ AI ML to solve a real world problem. Talking about the clear cut objectives, as you would have understood, first of all, reducing up the proxy attendances which students mark using the attendance app. Next, saving time by replacing manual attendance, and at the end, of course, applying AI ML in solving a real world problem. So, talking about the non technical key point of my project, the input would be a class photograph, and as it goes through my solution, the attendance would be marked on the official app. The purpose is to make things really simple for the professor and to save a lot of time. Now, talking about the technical key point, I would like to talk about two models which exist. One is deep face and the other is FaceNet. So, using deep face, you can detect faces in a picture, crop them, and normalize them and flatten the images in such a way that you can extract embeddings from it. And there is another model called FaceNet, using which you can extract embeddings and like map them with the student names. So what I am doing, or my solution is doing, is connecting these two models. By connecting these two models, we are solving the problem which I have stated earlier. Let's go through the process flow diagram. A photograph is input. Step 1. Faces are detected. Embeddings are extract. Now what embeddings are, we'll discuss in the later part. And next, embeddings are compared with some existing data, and the attendances are marked on the basis of similarity. Similarity that we are going to discuss in later part of the project. Let's start with the step 0, which is installing some dependencies. We are going to install DeepFace and OpenCV. So, like talking about installing dependencies, it's like just setting up the prerequisites, like ordering some machines before setting up a factory. So, similarly, like that, it's something like that in the Python and coding world. So, we use DeepFace. What DeepFace is, it's a model which gives you embeddings of a face. What embeddings are, we'll discuss, and like why I am using a model instead of creating my own is because like this is my first exposure to AI/ML. The course which we are doing is fundamentals of AI/ML. So like I would like start with zero first and then grow. Maybe I develop my own model in future. But right now I am just applying. I'm connecting two models. The second one is OpenCV, which is used to read the images. Now the question comes: embeddings. I've used this word embeddings 2-3 times, but what are embeddings? To state in very simple words, embeddings are nothing but a numerical representation of your face. It's a list of numbers, like some random numbers, not random actually, but some absurd numbers like 0.034 minus 0.22, 0.91. It's a list of such numbers which represent a face. You can think of it like the Aadhaar biometric. So what happens that the government doesn't store your actual fingerprint, but it stores some digital code derived from it. So face embeddings are somewhat like that. So like we can discuss some of the examples of embeddings. I think that would make things clear. As an example of embeddings, we can talk about the eye distance, like talking about the eye distance. So basically let me tell you about the core idea of embeddings. The core idea of embeddings is to get some information about those features of your face which are not going to change. Like we talk about the eye distance first. So no matter you wear specs or you not wear specs, doesn't matter you smile or you frown, this eye distance is not going to change. So this is stored in the form of, this is not actually stored in the form of your uh, physical distance, of course, but in the form of some vectors. And though that is one embedding. Next embedding feature which we can talk about is face symmetry. Like talking about face symmetry, just find the line of symmetry, divide your face. Let's say I print your face on a page of paper, on a paper, on a page, and then I fold it and I put it in front of some light, and I just shade the overlapping area, and some of the area is not overlapped. So we can define this symmetry as the shaded region by total region, area of shaded region by area of total region. So this is one example of face embedding. Next, a very good example is the distance between your cheekbones. See, you smile or you frown, the distance between your cheekbones does not change. This is a skeletal feature. Usually in embeddings, skeletal features are the best one. Similarly, there's your jawline angle, the degree of chin rounding, in fact, the forehead area by total face area. All of these things are represented in the form of numbers. And when we do so, then we get the mathematical map of your face, just like the biometric thing. But there is a question that why can't we not compare images directly? Why can't we just overlap and compare? There's a very simple answer to this question. It's that, in different situations, the photos of a person are different. In some photo, one person might be wearing glasses, and in the other photo, he or she might not be. There might be different lighting conditions. There might be different angles from which photo is taken. So that YOLO based approach is not a good idea. That's why it's good to use the embedding feature. And next, I would like to talk about some of the ethics. Like as we are talking, when we discuss AI/ML, then it is also important to talk about the ethics involved. Like your face data or any person's face data is sensitive, and it must be made sure that it is not collected without the consent of that person. So at least for my project, what I have done is that I have used the data of some which I'll be showing you in the demonstration part. I've used the data of some scientists, basically talking about what I am using as a class photograph is going to be the photograph that was taken in the year 1929, the Solvay conference photograph, where you can say that image had the highest average IQ. So there were 29 geniuses in one frame, and we'll be having a database of scientists whose images I have taken from Wikipedia, which are like freely available, copyright free. So that would also include scientists which were not present in that conference. After that, I would be showing you the demonstration that how this attendance marking takes place. So as we were talking about ethics, so hand in hand we should also talk about the bias. So talking about bias, whenever a model is biased towards a particular type of data based on how it is trained. So like talking about the deep face which I am talking, it was developed by a group of research scientists in Facebook. So it, although it used about 40 lakh images, but still it is a bit biased on fair skinned people. So because most of the images were taken from America and Europe. So like we have a solution to it. Like we can of course upload good quality images. That's a very good solution to it. And we can we can also we can also explore some other models for solving this problem. So let's go step by step. Step 1, which is like importing the relevant libraries. So I'll be telling you about the libraries which I have used. So the first one is Deepface, which is used to understand your face, your identity, load the data. Next is OpenCV. OpenCV is useful in working with images. NumPy, you know, it does the math. And Pandas stores the result as a data frame. Date time library simply notes the time, because time, date and time of attendance is also important. We use OS to access files in Google Colab. And for the conversion of images, for the display of images, we use PIL. And so we use some Colab patches to display images in Google Colab. Google Colab is the runtime environment which I am using. So now we move to step 2. This is uploading the student database. So first of all, this is a one-time process, and in our demonstration, this would have been already been done, because this is slightly a time-taking process, and basically the data is a static one. You don't need to do this part again and again. Now we upload the captured image in the while using the app. The class image is uploaded in one go, and it is very simple for the professor. The professor has to not upload these databases again and again, loading the face embeddings and all. These processes are already done when this is applied to a real app. Talking about the next step, which is loading the face embeddings. Now what this step does is although this step is also already done, because you initially we are talking about loading the face embeddings of the student database. So like names, you store images as names, like let's say bond.jpg, curie.jpg, and this extracts the embeddings, the facial features which we had talked about. Like it could be a list of sort of 0.23, 0.51 and something like that numbers. So what model we are using is FaceNet. FaceNet has 512 dimensional embeddings. So basically 512 features. There would be a vector. In simple words, there would be a list having 512 different numbers, which represents a vector. And like talking about a very simple point, that how we identify among all the files that which are images, we look at the extension. I have looked at the extension, like if that is JPEG, JPG or PNG. And for names, I look at the image name, simply because less that saves space. So yeah, like as I've said, we look at the extension and save the images by student names, which requires a little bit of less space. Now talking about step 5, this is like one of the important steps: detecting faces on the class photograph. Now this is done on the class photograph which is entered. What happens is, a class photograph comprises of many objects like benches, chairs and all, but it also comprises of faces. Faces is our main focus. So this step is before recognition. So from the entire class photograph, the model identifies that which things, which part of the photograph comprises of faces. So talking about that, how it does, because a face has some basic features like two eyes, one nose, one mouth, and it also looks into the symmetry thing, and that is how it identifies. Now talking about The step 6, so we define a cosine similarity function. Now we are at the step 6 of our solution, that is defining the cosine similarity function. Now what is the cosine similarity? It is a simple function that measures the cos of angle between two vectors. So what would be these two vectors? So the first vector would be the face embedding from the student database, and the other vector would be the face embedding from a group photograph. So there would be n number of vectors over here from the group photograph, and n number of vectors from the student database. Now what happens that the cosine similarity is calculated. Talking about the cosine similarity, it comes to be 0 if two vectors are same, if they are parallel, because of cos it cos 0 cos 0 degree, it comes to be 1. I'm sorry, yeah, like cos 0 degree 1. And if two vectors are not related, then cos 90 degree comes to 0, the cosine similarity is 0. And if they are oppositely related, then the cosine similarity comes to be 1 that because of cos 180 degree. So these similarities are matched, and the maximum similarity is calculated. Actually the best match is calculated, and whatever is the best match, you match that student database to that face from the class photograph. And this is done using a simple dot product. A vector dot b vector is equals to mod a mod b cos theta. But there's a catch, like what if all the similarities are less, like 0.2, 0.4, and those numbers? Then in such a case, what we do is we set a threshold, so that it's not like you get similarity as among all the worst, you get the best similarity and you match the face. So yeah, so that is not possible. We do this. Now we are at the last step, that is marking the attendance. This is a simple step. In this, the attendance is stored in a CSV sheet, now which can be linked to a student app, or like that can be linked to a dynamic Google sheet, uh, which can further be linked to a Django database, and that can be linked to the attendance app, and the attendance can be marked. Now we reach to the solution demo part. So I'd be going with the solution demo now. So yes, let's start the demo. I'm going to run the code. In the meantime, we can just go through the data. Like you can see, here are the images of known students, like Archimedes, Bohr, Bond, Bragg, and the names of all the scientists. I can show you how the pictures are. Like we can just see, open one picture in the meantime while the code is running. So this sort of faces are there. Has the god himself, Newton. And talking about the class photograph, so of course Newton would be absent because he was not a part of the Solvay conference. And yeah, this is the group photograph from Solvay conference. There are 29 scientists over here, and I think the code is, yeah, it's almost run. So here we have detected phase 1, 2, 3. 29 faces have been detected, but the embeddings which were extracted were 33. So like 4 scientists are not present, they are absent, and here the attendance has been marked successfully, and you can just check the attendance.csv. And here, yeah, here you have the details. But you will see that here you won't find Newton, you won't find Galileo, and yeah, that's it. Thank you for your time.